this video, we are going to define what a relation is, how a function is a type of relation, as well as talk about domain and range, and we're going to determine whether or not a relation is a function using mapping diagrams. Let's jump right into it. So we're given some definitions here. I'm going to go over those briefly. A relation is a relationship that pairs an input value to any number of output values. So that means that we could have the number 2 as an input. So let's say I work for 2 hours, you work for 2 hours, and someone else works for 2 hours, and I get paid $10, you get paid $30, and someone else gets paid $40. Everybody had an input of 2, but we all had different outputs. That would be a relation. However, it's not a function. A function is a relation, so a specific kind of relation that pairs an input value to exactly one output value. So because in that last example, each of us had an input of 2 hours, but we all had different outputs, that would not be a function. It's strictly a relation. Very cool stuff. So we're going to determine in this video what makes a relation a function. Now in previous videos, we have discussed only functions before. So we're going to add to it a little more formally an understanding of this stuff. The domain is just another word for all the possible input values. So that 2 that we talked about is part of a domain, right? So the domain are all the possible input values. Very often you'll see the domain as the x value in a point or an ordered pair. A range or the range are all the possible output values. So very often you will see that as the second column in a table. Domain would be the first column in a table, or the y values would be the ranges, very often in ordered pairs. So here I've given you a set of information. These little brackets at the end here is just saying here's a set of information, and these are all points. The inputs would be -2, 4, 1, and 0. So that would make up your domain. Your domain would actually be the numbers 0, 1, -2, and 4. You'd usually write that from least to greatest, so starting with -2. I'm not going to go over how to formalize domain and range. That's going to come in a later video, probably in an Algebra 1 section. Stay tuned for that. Just figured I'd mention it now to get you a little bit experience with it. The range would be all the y values, the outputs, 6, 4, 8, and 1. Very, very cool. Oh my goodness, that alarm, do you know what that means? It means I go off camera for a second and then tell you it is time to determine whether or not relations are functions. I know, terrible sound effects and everything, but I figured I'd go with something a little different in this video. So anyway, let's check out whether or not each relation is a function. So now we've got this, x and y. We need to determine whether or not this is a function. It is a relation because we have numbers being paired from inputs to outputs. But is it a function? We use what's called a mapping diagram. A mapping diagram literally lists out all the terms in the domain. So that would be, without repeating them, that would be 0, 1, 2, and 3. You don't want to repeat the 1, because if that 1 goes to 2 different y values or 2 different outputs in the range, and we repeat the 1 here, we might not catch that the 1 went to 2 different places. So we only write each term or each number that occurs in the domain once, even if they repeat more than once. The range, go from least to greatest, -3, 1, then 2, 5, then 7. I'm just listing out all the numbers there. And what we do is here is we draw arrows connecting each number's input to the output it corresponds to. So 0 goes to -3. So far, it is a function because 0 has only gone to one number. 1 goes to 2. So far, this is a function because 1 has only gone to one number in the range. So each number in the domain has gone to one number in the range, or each input value has gone to one output value. 2 goes to 1. 2 has only gone to one number, so we're good. 3 goes to 5, still a function. 1 goes to 7, oh. Do you see right here? 1 has now gone to 2 as well as to 7, meaning this is a relation, but because the number 1, the input value, goes to 2 different y values in the range, this is not a function. So it is a relation, but not a function. All right, so that's it. That's how you do a mapping diagram. Draw out the domain, draw out the range, and connect the corresponding domain and range parts. Let's do a couple more examples of this. So we've got the domain right here. So I've got a list of numbers now, just presented to you differently. It's just like having a table of data, the range. We're going to list everything out from least to greatest. So the x values, we have 0, 1, 2, and 4. I'll list those out. That would be our domain. Our range would be all the possible y values listed from least to greatest. That would be 1, 2, and 3 happens twice. 1, 2, and 3. So now we're going to connect the corresponding pieces here. 0 goes to 3. So far this is a function because 0, the input, goes to only one y value. 1 goes to 2. So we've mapped 1 to 2. Still a function, 1 has only gone to one y value. Let's see, 2 goes to 3. 2 only goes to one y value. So still a function. 4 goes to 1. So this is a function, this relation, because every member in the domain or every input value goes to exactly one y value. Now you might notice that both the numbers 0 and 2 map to the same y value. That's okay, it is still considered a function. And if you're still hungry for more, I've got one more bonus example. We'll go back to this original one here and we'll map everything out and see if this original problem that I used to discuss domain and range in the beginning of this video is a function or not. Okay, so the domain, we go from least to greatest, is -2, then 0, 1, and 4. And the y values go, let's see, 1, 4, 6, and 8. So -2 goes to 6. So far so good. 0 goes to 1. There we have it. Let's see, 4 goes to 4. Sorry, I went kind of out of order there. And then let's see, 1 goes to 8. Every single value in the domain goes to one value in the range. There are no repeated inputs going to different outputs, and therefore, this is a function. Some of you might be able to just look at the problem and say, well, there's no repeated x value, so I know that there's no input that will go to two different y values. Whereas here, there's the repeated x value of 1, and it goes to both 2 and 7, so therefore it's not a function. There you have it, peeps, being able to tell whether or not a relation is a function using mapping diagrams. Awesome, awesome stuff.